All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna be doing more Git stuff. We are gonna be trying to get good, if you get what I'm saying. That was a bad joke, but anyways. So um, today I think we'll directly jump into our Git studies, and hopefully after this stream, I'm gonna do the mute stream, which is data science lab. I think that's what we had decided the name was. I don't remember. But yeah, during yesterday's stream, we were discussing this thing. Give me a second. How do I edit this cell? Oh, there it is. Yeah. So during yesterday's stream, we were discussing this, and I kind of like the idea of doing two separate streams, one talking stream and one mute stream. That way, something I could do is I could finish the talking stream and then take a short break, maybe half an hour, maybe 1 hour or something, and then I can start up the mute stream, which I can do for maybe an hour or 2 hours or something. And during that time, I can choose one of these activities. Give me a second. Here, I can choose one of these activities. Either we're going to explore a data science technique, or we're going to play around with some neural network architectures. I still have quite a bit of experimentation to do and quite a bit of exploration to do with feed-forward neural networks, and I also still have to learn about convolutional neural net. Or well, I still have to learn the practical side, I should say, of convolutional neural networks, and just in general learn about recurrent neural networks as well, because I haven't touched CNNs and RNNs like at all. At least practically, I haven't touched either of them. I'm still I'm still on what is it? Feed forward. Yeah, I'm still on feed forward neural networks because there's quite a bit to explore there, and I wanted to take my time with exploring it and trying different things to see how I can just in general. I'm not even sure what I'm looking for. I just want to play around with it so I can get a better idea of different how different components, different types of methods affect the final result. And actually, not even just the final result, even stuff like, I don't know, training, for example. There's a lot to explore there. That's one of the reasons why I want to take some time to just do dumb stuff with neural networks, because that way I'm gonna learn a lot about neural network architectures. But yeah, um, right now we are doing this stream, which is gonna be playing around with Git. I probably should have I probably should have what is it? VS Code. I probably should have VS Code open instead of this Kaggle notebook, because I believe in this chapter we go into using like a bunch of commands and stuff. Okay, you know what? Here's what we can do. I think I had set up the thing on I don't remember where I set it up actually. Give me a second. Let me open up VS Code and see where I had set it up, if I did set it up at all. I don't think I'd set it up here. I think I'd set it up um, on my Linux machine. I'd set up a just a bare bones project to use with Git, and this was before I'd looked into um, Git for VS Code. So, okay, Git for VS Code is also something that I need to explore, kind of side by side while learning about Git. I also want to explore um, Git for VS Code or the VS Code source control thing. I'm not sure what to call it. Well, okay. I think it's just the source control tab, the version control. I think it's source control. Yeah, it says source control. Git source control. I need to explore how source control works in Git itself. Um, because I'm gonna be using Git. Should I be using? Uh, did I say because I'm gonna be using Git? No, I said I meant because I'm gonna be using VS Code. Oh, you know what I could do? I can open up VS Code. I can use the terminal. I will not touch the the source control tab, just so I can go along with the tutorial. I'll not touch the source control tab. Yeah, that'll be better because that way I can stick to the command line interface, and I can stick to entering commands and stuff. Uh, Give me a second. I'm still opening up VS Code. Actually, you know what? While that opens up, we can read. Um, no, you know what? Let's actually. I don't think there's too much to look at in the previous chapter. I think. Sorry, zoned out. Give me a second. Okay, yeah. So, what was I saying? I forgot what I was saying. I completely forgot what I was saying. Anyways, we're gonna start with this. I've already done this chapter. It's basically just initializing the Git repo and, well, initializing the Git repo within a directory, or um, I think I think cloning another repo. I think that's also an option. Yeah, cloning an existing repository. So we're not going to be doing the cloning. Um, we will actually. I should probably read this section anyways, because I just skipped it completely. Uh, because I was initializing a new repo. I just skipped the thing completely. Yeah, let's not do that. Let me we can start by reading this, but before that, I need to create a directory. Oh, dude, I hate working with VS Code on my streaming machine. I'm tempted, honestly, I'm tempted to I could do that. I could set up yeah, I could set up the repo on my other machine, on my Linux machine, and run it from there. I could run VS Code from there. I mean, give me a second. I'm just doing the whole open folder thing in VS Code. I'm going to create the new project. This is under projects. Okay, no. I think I have a VS Code projects folder. Yeah, I do. Okay, here I can create a random folder. Okay, and in here I can create a learning Git. Wait, give me a second. Yeah, okay. In here I can create learning Git 01. Now let me select this. Actually, I just realized I don't think I ever set up the variables for Git. Because like when you okay, let me show you guys what I mean. In the previous chapter, they showed after you install Git in your first time setup, there's going to be a couple of variables that you're going to want to set. Um, Stuff like this, for example, username, user email, and there was one more thing, editor. Yeah, I think the editor is already set because in the setup I had yeah, in the setup I had selected VS Code. They had a list of options that you can select from for different types of editors, and I selected VS Code because I plan on using VS Code. So that should be set already. I guess the only thing I need to set is the identity related stuff. So user.name, user.email. Give me a second, let this thing open up, and then give me a second. This is taking some time. So yeah, once this gets set up, we're gonna um, we're gonna start by initializing the repo, and further from that point, I can start making changes to the thing and staging those changes, and then committing those changes, and we could also try to like revert to a different version, stuff like that. Okay. Um, First things first, let me check. Oh, you know what? At this point, I think I can do it. So here's what I'm gonna do. I'm gonna switch. Which one am I trying to switch? This one. Okay. I think we are good. Okay. So in here, let's start with get help. Okay, so we know that get help works. Git, I forgot the command, config. Okay, git config global user.name. Oh, it set a username. Okay, damn. Okay, okay. Give me a second. I don't remember ever typing that in, so I'm not sure where it pulled that from, but that's okay. There's just something else that I want to check. Oh God. Right. So I guess the first thing I need to do is reset these. So we're going to do global user dot name is just dem keys, and then global user dot email. Oh wait, holy shit. I probably shouldn't be change. No, you know what? I can change it later. I think I know where it pulled it from, because I think when you install GitHub for desktop, or GitHub desktop, just GitHub desktop, I think it creates its own sort of config or settings or whatever files. And so when I installed Git, it sort of automatically pulled the information that was already existing on the system. And the existing information is gonna be my GitHub account related stuff. So I guess that makes sense. Okay, now we should be good, but let me run this again and see what shows up. Okay, we are good. Okay, all right. So the configuration is done. We can probably also check for the code editor, code.editor. Oh, nothing pops up here. Um, how do I go about this? What's a good way to go about this? I mean, I could look for where VS Code is, but then what um what should I be using here? As in, I mean, I want to use VS Code. That's like for sure. But I'm trying to think of any extra flags or something that I might need to set up with it. So okay, you know what? We'll do that when the time arises, when the need arises. For now, Git init. Okay, so we have initialized the Git repo. Uh, I don't know if this shows the Git folder. Like the folder is probably there. The folder does not seem to be there. Where is it? Uh, okay, hold on. The directory command might have what is going on. ls lsa possible matches hidden. That's what I'm trying to look for. Okay, there it is. So our Git folder is hidden, and it. I mean, okay, our Git folder exists, but it's hidden. So that's probably why it's not showing up here. Okay. Um, what next? So we're gonna start with the first chapter. Did I open that up on a? Yeah. Wait, no. Okay. Let's. Right. If you can read only one chapter to get going with Git, this is it. This chapter covers every basic command you need to do. Every basic command you need to do the vast majority of things you'll eventually spend your time doing with Git. By the end of the chapter, you should be able to configure and initialize a repository, begin and stop tracking files, and stage and commit changes. We'll also show you how to set up Git to ignore certain files and file patterns. Wait, how to set up Git to ignore certain files and file patterns, how to undo mistakes quickly and easily, how to browse the history of your project and view changes between commits, and how to push and pull from remote repositories. All right. Getting a Git repository. You typically obtain a Git repository in one of two ways. You can take a local directory that is currently not under version control and turn it into a Git repo, or you can clone an existing Git repository from elsewhere. In either case, you end up with a Git repository on your local machine ready for work. This is for initializing a new repo. Okay. This creates a new subdirectory named Git uh, that contains all of your necessary repository files, a Git repository skeleton. Okay. At this point, nothing in your project is tracked yet. See Git internals for more information about exactly what files are contained in the .git directory you just created. If you want to start version controlling existing files as opposed to an empty directory, you should probably begin tracking those files and do an initial commit. You can accomplish that with a few git add commands that specify the files you want to track, followed by a git commit. We'll go over what these commands do in just a minute. At this point, you have a Git repository with tracked files and an initial commit. You know what? Okay, let's stick with it. Let's do this. Okay, so test01.txt. We'll open up this file. This file has some text. Great, awesome. So now we do git add test01.txt. Okay, cool. Let's try adding git license, even though there is no license file, so it should throw an error, but let's do it anyways. Okay, cool. So it didn't find anything. So then we do git commit m, and I'm guessing this is for like single line comments, or if you want to enter the entire message into this. Actually, I wonder if this is going to be the title of the commit or the body of the commit. Because like with the commit, you can attach a message as well, and that message has a body that's the commit's title. Actually, did I just say body? No, okay, let's restart. With your commit, you can attach a title and a body. I'm going to stop saying message. So you can attach a title and a body. In the body, you can have like multi-line text. So in there, you can go into like full detail about what exactly this commit has in it, what changes, what additions, what removals, or whatever. And the title, it just has to be a title. It has to be small. It has to be concise and somehow explaining everything within that one title. Because then you also have the body in which you can actually explain everything, right? This actually no wait. Let's call this initial commit. Okay, so we have something going on here. We'll go over what these commands do in just a minute. At this point, you have a Git repository with tracked files and an initial commit. All right, let's read the cloning section as well. If you want to get a copy of an existing Git repository, for example, a project you'd like to contribute to, the command you need is git clone. If you're familiar with other VCSs, such as Subversion, you'll need you'll notice that the command is clone and not checkout. Okay, this is an important distinction. Instead of getting just a working copy, Git receives a full copy of nearly all the data that the server has. Every version of every file for the history of the project is pulled down by default when you run git clone. In fact, if your server disk gets corrupted, you can often use nearly any of the clones on any client to set the server back to the state it was in when it was cloned. You may lose some server-side hooks and such, but all the version data would be there. See getting git on a server for more details. We are definitely going to explore that for some time later. Okay, you clone a repository with git clone so and so. For example, if you want to clone the git linkable library called libgit2, you can do so like this. Okay, that creates a directory named libgit2, initializes a git directory inside it. Oh, okay, hold on, that's interesting. So it creates a directory named libgit2. Then it initializes the git directory inside it, and it pulls down all the data from that repository, and checks out a working copy of the latest version. So I think I need to understand the terminology here of checking out. Um, I don't know if that's being explained here or not, because it seems, yeah, yeah. Uh, Either it was covered somewhere else and I missed it, or it was just not covered and they're under the assumption that we know it already. Because like I've heard about, checking out files, but I don't like fully understand what that means. So maybe I should refresh. Is this refreshing? Yeah, it is. Give it a second. Oh, okay, cool. So I'm learning about Git. Help me understand the concept of cloning, or no, let's not use it in that way. Clone and checkout. Okay, cool. Let's start with clone. We already have an idea of what cloning does, but let's read the thing anyways. When working with Git, the commands git clone and git checkout serve distinct purposes and are used for different stages of your workflow. Dude, I just remembered that there's that visual cheat sheet, the Git visual cheat sheet. I should have that open, because that's gonna be helpful, especially now that I'm learning Git. Like, I'm learning all the commands and the different things that happen within the repo, and how things work within the repo and all of that stuff. I feel like looking at the visual cheat sheet is definitely going to be helpful. Um, Basically for visualizing. They serve distinct purposes and are used in different stages of your workflow. Git clone. The purpose of git clone is what? No. Purpose. Git clone is used to create a local copy of an existing Git repository from a remote server or another local repository. This command this command is typically used when you want to start working on a project that you don't yet have on your local machine. To clone a repo, you do this, replace this with that. Okay, that's an example. Great. Cloning a repository into a specific subdirectory. Okay, that's good to know. That is good to know. Cloning a specific branch. Oh shit. Okay, you can do that as well. Cool. Good. Good. I didn't know. I guess they were gonna cover that in the branching section. Alternatively, you can use single branch, so and so. Okay, fine. Git checkout. Git checkout is used to switch between different branches, restore working tree files, or check out specific commits or tags within an already cloned or initialized Git repository. Wait, where was I? Yeah. This command is used to navigate between different branches or versions of a project that you are already working on locally. Oh, you know what? To update your local branch with the latest changes from. Oh shit, I missed the ad timer. Okay, so there's going to be an ad playing in like, I don't know, 15 seconds or something. But whenever the ad starts, I'll take a hydration break and then we will resume. Wow. Uh, this ad is taking some time to start. Okay, in the meantime, let's carry on reading. So, key differences. Git clone creates a new local. Okay, so I understood what git clone does. Checkout apparently has a bunch of different purposes. Checkout changes the current state of your existing working environment by switching. Okay, there's the ad break. I'll take a hydration break and I'll see you guys in 30 seconds. All right, welcome, welcome back. Uh, okay, git checkout changes the current state. Give me a second. Okay, git checkout changes the current state of your existing working directory by switching branches or checking out specific commits. Okay, let's keep cloning aside. Let's keep cloning and branches aside for a second. Let's go into more detail about what checkout actually does, because I feel like I haven't fully understood. Also, well, okay, I've kind of understood, but I'm just saying it in this way so that the LLM will explain it to me. Also, what is so it mentioned something about a working tree thing. I want to get a better idea of exactly what that is, what that represents. Uh, what is no? Also, you mentioned working tree files. What is that? Wow, holy shit! There's a lot of information here. Okay, to understand the git checkout command and the concept, dude, you know what? Okay, I wonder if there's going to be a section later on where git checkout is going to be explained, because I've had this happen before where I rushed to look for, the meaning of something, and like 2 or 3 lines or 2 or 3 pages later, that thing that I was looking for, it got explained. Um, right. So let's not look at, I mean, they should mention it before branching as well, because branching is not the only branching is not the only thing that uses git checkout. Okay, okay, okay. At any point is checkout mentioned here? No. Uh, Recording changes, undoing things. Let's try undoing. Okay, all right. Unstaging files, okay. Unmodifying a modified file, and there's git checkout. Where is git checkout specifically covered? Because, oh, they have a thing here called reset demystified. We'll go into much more detail about what reset does. Right, so there is a reset command. Um, it's true that git reset can be a dangerous command, especially if you provide the so-and-so flag. However, in the scenario described above, the file in your working directory is not touched, so it's relatively safe. All right, okay. Now, where does git checkout get mentioned? I wonder if I should just search for this. Yeah, give me a second. Otherwise, we can just carry on. Sorry. Otherwise, we can just carry on reading whatever Llama said. Git checkout. Okay, there's I think that's the reference. That's like the API, I guess, or the docs in general. That is not mentioned in the book. In the book, it's mentioned in different ways. All right, you know what? Yeah, we are probably gonna have to get help from Llama for this. So we're gonna carry on reading this. To understand the git checkout command and the concept of the working tree in Git, here's a detailed explanation. Git working tree. The working tree in Git refers to the directory where you perform edits and modifications to your files. Um, it is the current snapshot of your project, containing all the files and directories that are being tracked by Git, as well as any modifications, new files, or untracked resources. When you clone a repository or initialize a new repository, the working tree is created and contains the latest version of every file from that repository. Where was I? Um, when you, yeah, from the repository. The working tree is separate from the Git directory. I was just about to ask that question, like, is the working tree part of like the staging file? Is it described in the staging file? The working tree is separate from the Git directory, which stores the repository's metadata and object database. Changes made in the working tree are tracked by Git, and you can see these changes using commands like git status. These changes can then be staged can be staged to the index or staging area and committed to the repository's history. Git checkout command. The git checkout command has several uses, primarily focused on updating the working tree to match a specified version or branch. Switching branches. When you use git checkout so and so, it updates the working tree to match the files and directories as they exist in in the specified branch. This command also updates the head reference to point to the git checkout branch. Checking out commits. If you use git checkout commit hash so and so, it updates the working tree to match the files and directories as they existed at the specific commit. This puts you in a detached head state, meaning the head reference is no longer okay. So now there's a new thing I need to look into, head, because I've seen this mentioned before as well. Oh, you know what? I think the head thing is going to be covered in the next chapter, so maybe I should be a little patient with that. This puts you in a detached head state, meaning the head reference is no longer at the tip of the branch, but rather at the tip of a branch, but rather at a specific commit. This is useful for inspecting past versions of your project and making experimental changes without affecting any branches. Okay. Um, okay, so there's some interesting stuff. There's some interesting experimentation that I can do with this. Like, for example, jumping back to a previous version, um, and then doing a commit from there and seeing where the commit lands. Like, does it land right after the current commit that we have jumped to, or does it go to the tip of the branch? So, like the very first, the very last, what to call it, the very top, the very latest. Uh, okay. This is useful for inspecting past versions of your project or making experimental changes without affecting any branches. Checking out files. You can also use git checkout to restore specific files from the index or a commit to the working tree. For example, a git checkout file will restore the specified file. I keep stopping at specified because I'm about to say specific, but then it turns out to be specified. Okay, git checkout will restore the specified file to its version in the index. What? Git checkout will restore the specified file to its version in the index. Oh, in the index or the last commit. Okay, all right. So that's a good way to restore a specific file to either the last staged change or the very last committed change. So like to one of those versions, one of those states. Okay, this is to switch to a branch. This is to check out a specific commit. This is to restore a file, create and check out a new branch. Okay, what is head? Oh, sorry, I was busy with something. Okay, right. In Git, head is a crucial concept that helps track and manage the current state of your repository. Here's a detailed explanation of what head is and how it works. All right. Definition of head. Head. My God, dude. All right. I keep calling this head, and in the back of my head, there's like just dirty jokes going on. But okay, um, head is a reference to the current commit on the currently checked out branch. It acts as a pointer or a symbolic reference to the latest commit in your current branch. Oh, so head is just a pointer. Head just tells you where. Um, head is the pointer that. Wait, no. What's a good way to like visualize this? Because like we mentioned something about putting the head in a detached state. Um, okay, all right. Head is a reference to the current commit. I think I read this already. How head works: pointer to the current commit. When head points to a branch, it indicates the latest commit on that branch. For example, if you are on the main branch, head will point to the most recent commit on main. Real quick, let's see what happens if we do git status here. On branch main, nothing to commit, working tree clean. Oh, there's nothing to commit because I already committed the thing. Um, okay, let's do another. Uh, this is a change to the file. Okay. So now we. Okay, what happens if I do git status now? Okay, changes not staged for commit. Oh, good. Okay, so it's reporting that so and so file has been modified. No changes added to commit. Use git add or git commit. Okay, git add. What if I just do this? Nothing specified, nothing added. Maybe you want to say so and so. Okay, what did that just add exactly? Oh, cool. Okay, so it adds the, I'm guessing dot adds the entire current directory. I think I should also look into, well, I was about to say I need to look into if there's like an all flag, but considering that we are already in like the root of the project, I think, yeah, I don't think the all flag would be necessary. Considering we are in the root of the project, it's gonna anyways add all the files and all the directories. Yeah, yeah. Okay, cool. So now we commit this. Uh, I guess second commit. Changes to be committed. So and so, so and so. Okay, all right. What just happened? What is? Hold on. What just happened? Second commit. Why did that just happen? Oh, did I hit? Maybe I hit Shift Enter. Maybe that's why it happened. Let's try this. Test. Okay, it didn't happen in that case. Okay, whatever. Hold on. Um it says one insertion and one deletion. What got deleted? I didn't I don't think I deleted anything. Did I? I don't think I deleted anything. Okay. We can look into that later. Uh okay, file representations. The state of the head. Hold on. Pointer to current commit. When head points to a branch, when head points to a branch, it indicates the latest commit on that branch. For example, if you're on the main branch, head will point to the most recent commit on main. File representations. The state of head is stored in git slash head file within your Git repository. This file can contain either the name of a branch, like so and so, or a specific commit tag. No, a commit ID. Normal head state. In a normal state, head points to the latest commit on the currently checked out branch. This means that when you run commands like git status, you will see a message indicating which branch you are on, such as on branch main. Yeah, I think it showed that, right? Get status. I spelled status wrong. Okay, give it a second to give an error. Damn, this is taking some time. All right, while this takes its time to give the error, I'll carry on reading. This means that when you run commands like git status, you will see a message indicating backup. There it is. Okay, cool. On branch main, nothing to commit. Working tree clean. All right. Detached head state. A detached head state occurs when head does not point to a branch, but instead points directly to a specific commit or a remote branch. Wait, it says it does not point to a branch, but instead points directly to a specific commit or a remote branch. What is a remote branch? And how is that different from the repo having a branch? What? So, okay, you have the repo, right? The repo has a branch, let's say, and I think the remote part is what's confusing me. Okay, anyways, this happens when you check out an older commit, a tag, or a remote branch using its SHA-1 hash or name. In this state, any new commits you make will not be part of any branch unless you create a new branch starting from the detached head. Oh, so I guess that answers my question of what happens if you commit when when you have, I'm not sure how to say that, when you have currently checked out or when you're currently checking out an older commit. This happens when you check out an older commit and so on. So okay, I guess the best way to say it is when you have checked out an older commit, then you cannot commit from that point because you're in a detached head state. You cannot apparently you cannot commit from there unless you create a new branch, starting from the detached head. Okay. Example scenarios: switching branches. When you switch branches using git checkout so and so, head moves to point to the latest commit on the new branch. Head moves to point to the latest commit on the new branch. Checking out a specific commit. If you check out a specific commit using git checkout commit hash, head will point directly to the commit, putting you in a detached head state. Detached head, detached head example. If you check out the first commit on the main branch, if you check out the first commit on the main branch, head will no longer point to main, but to that specific commit. This is indicated by messages like head detached at commit hash when you run git status using head in git commands. Head can be used in various git commands as a shorthand for the current commit. For example, git diff head compares the working tree with the current commit. Git log head shows the commit history starting from the current commit. Git reset hard head uh, re- resets the working tree and index to match the current commit. Okay, all right. How am I supposed to use checkout in a sentence? Um, do I say checking out or checked out or something else? I think I should have mentioned Git specifically. Yeah. When using Git, how am I supposed to so and so? Uh, okay, let's read. When discussing the git checkout command in sentences, the correct verb forms and context are important for clarity. Here are some examples of how you can use checkout in different contexts. Switching branches. Present tense. I'm checking out the main branch. Okay. This indicates the action of switching to the main branch. This indicates the action of switching to the main branch is happening now. Past tense. I checked out the feature branch earlier today. This indicates the action of switching to the feature branch was completed in the past. Okay, I'm checking out and I checked out. Okay, checking out a commit or tag. Present tense. I'm checking out the commit from last week to review the changes. This indicates the action of uh, moving to a specific commit is happening now. I checked out the tag so and so to the state. Oh, that's interesting. I checked out the tag. Oh, to see the states. I was about to. I was about to say that. Oh, we are checking it out to a specific state, but now this says to see the state. See the state of the project at that release. This indicates the action of moving to a specific tag was completed in the past. Restoring files. Okay. General usage. To switch branches, you need to use the git checkout command. Here checkout is used as a noun referring to the command itself. After checking out the new branch, I started working on the feature. Here checking out is used to describe the action of switching to a new branch. For example, to start working on a new feature, I will check out a new branch using git checkout. Oh, you don't say create a new branch? Or is saying I will check out a new branch the same as creating a new, because it does say new feature here, right? Git checkout. Yeah, this isn't this to create a new feature? This is not to switch to a different branch. Okay, cool. I checked out the main branch to ensure my changes are up to date. If you need to review an older commit, you can check it out using git checkout so and so. Okay. In summary, checking out the present is a present participle form. Okay. All right. Is a present participle form used when describing the action as it is happening. Checked out is the past tense form used when describing the action as completed, and checkout can be used as a noun when referring to the command or the process itself. Wait, back up. Checkout can be used as a noun when referring to the command or the process itself. When referring to the command or the process. Okay. I still have some questions about how we are supposed to use checkout in sentences, but okay, for now I can let it go. Oh, uh, how do I see what head is currently pointing to? Status doesn't mention it. Git show head. Oh my god, dude. Okay. Um. Okay. Okay. Sorry. Um. To determine what head is currently pointing to in a Git repository, you can use several methods. Uh, check the file. Okay, that's fine. I'm not going to be looking at the file. Um, dude, no. Okay, you know what? Let's do that. Let's do that. So ls a, not a, hidden. Let's do dot git. There's apparently nothing in. Wait, where do I mention this? Okay, is there nothing in? Oh God. All right. Okay, cool. So there is a head thing in there. Is cat a thing? Let me see if that opens up. Cat git head. Oh, that's all it contains. Okay. If head contains a branch name, it will look something like this. And if head contains a commit ID, it will be a SHA-1. It will be a SHA-1 hash like so and so. I wonder if it'll contain a commit ID if there's something to be committed. So like, okay, what if I just did a commit for no reason? Would that work? Let's say third commit. Did that did that do anything? Did that work? Actually, I wasn't supposed to. No, hold on, wait. I wasn't supposed to commit. Why did I just commit? Actually, I don't think it committed. Okay, anyways. Uh add so and so. Okay, then let's do status. Right. Okay. Some text. Okay, that's been added. Now, let's read this. Okay, it still doesn't contain the commit thing, but if I do git status, then it's going to mention I spelled it wrong. Great. Git status. All right. Okay, git show ref. You can use the git show ref command to see where head is pointing. This command will display the commit ID that head is currently referencing. Okay, git show ref head. Verify? What does verify do? Okay, so that's what head is currently pointing to. Now, what if I do a commit? Third commit. What is going on, dude? Why? Why is it doing that? Okay, git commit. Third commit. Yeah, I'm not sure. I'm not sure why it does that every now and then. Okay, cool. So let's take a look at head now. Head is completely different now. So it's currently pointing to the latest commit, which is I just noticed something interesting. I'm guessing this is the latest commit ID, and I just noticed that this matches the first few characters of the hash. That's interesting. Let's test out okay, some more text. Okay, let's do add, then commit, fourth commit. Does fourth have a U? I think it does. 40 doesn't have a U. Does fourth have? Yeah, because otherwise it would be like fourth, right? But then again, English has all sorts of like weird stuff like that where you can't say for sure what the pronunciation is going to be. I think it's U. I think there's a U. Okay. Anyways, right. So now let's check. What was it? This. Yeah. Okay. That's interesting. That's interesting. So it's showing the first few characters of the hash. I guess I'll find out more about that later. Okay, what else can I use? Git log. Running git log can show you where head is pointing. Look for the line that indicates head or just head if you are in a detached head state. If you see head main, it means head is pointing to the latest commit on the branch. If you see head, it means head is in a detached state. Oh, that's what this was saying. Okay, I think so. Yeah, yeah. All right. Uh, it means head is in a detached state pointing directly to a specific commit. Using git status. Um, the git status command provides a quick overview of the current branch and whether head is detached. If you see on branch main, it indicates that that head is pointing. So it's not directly going to mention that head is pointing to that, but like the assumption is that yeah, head is pointing to that because it says that we are on branch main. If you see head detached at so and so commit, that's interesting. Head detached at commit. And that's to indicate that head is currently in a detached state, pointing directly. Okay, so I was about to say, okay, the head is detached, but it's not pointing to anything. But no, the head is in a detached state and it's pointing directly to a specific commit. So what it's detached from is the main branch, or well, yeah, not necessarily a branch. It's detached from the latest commit, isn't it? Okay, wait. Then git show head. You can use git show head command to see the details of the commit that head is currently pointing to. Let's do that. Oh, that's interesting. Okay, that's dude. That's interesting. It's also displaying it in like a different way. It's showing what was the old stuff and then what was added new to it. Cool. Okay. All right. Um. Okay. What was I? When you say head detached at commit hash, are you saying that no? What exactly is what exactly has the head been detached from, and what exactly is it connected to right now? So I know that it's connected to or pointing to whatever commit you told it to point to. I'm trying to understand the detached from. Okay. When you see the message head detached at commit hash, it indicates that the head pointer in your Git repository has entered a detached head state. Here's what this means. What has the head been detached from? In a normal state, head points to the latest commit on a specific branch, main, feature, etc. However, in a detached head state, head is no longer pointing to a branch reference. Instead, okay, this is important. So in a normal state, it's pointing to the latest commit on a specific branch. However, in a detached head state, head is no longer pointing to a branch reference. Instead, it has been detached from the branch it was previously on. What is the head connected to now? When head is detached, it points directly to a specific commit identified by its hash. This means that the head is now referencing a particular commit in the repository's history rather than the tip of a branch. This state allows you to work directly on that commit without affecting any branches. Implications. In this state, any new commits you make will not be part of any branch. These commits are essentially orphaned. Oh, okay. I've seen that term before and I had no idea what it meant at the time. These commits are essentially orphaned and can be discarded or saved by creating a new branch from the current detached head position. If you want to preserve these changes, you need to create a new branch using git checkout so and so. All right, dude, the more I'm learning about Git, the more I'm able to appreciate how sophisticated this entire system is. Okay, Git status gives so and so, Git checkout detach head, Git status. How do I see commit history? Oh wow, there's quite a bit of data. Holy shit. All right, let's go through all of it. To view the commit history on to view the commit history of a Git repository, you can use several commands and methods, each providing different levels of detail and customization. Here are some of the most common ways to view commit history. Git log. The git log command is the most straightforward way to view the commit history. This will display a list of the latest commits in chronological order, showing the commit hash, author, date, and commit messages. Navigating the log. You can navigate the log by using the less terminal pager or sc- using J or down arrow to scroll. Okay, all right, fine. The spacebar or page down to scroll down by one page, or be oh that's in case the list is long. Okay, customize the customize the output. Wait, what is that? What does that look like? Git log. Oh, that's why you need to scroll. Okay, that makes sense. That makes sense. So on Linux, usually I would just be looking at the less version, but like here, actually here also it's not all that different because I'm able to do this, right? It's essentially that. Okay, cool. So these are all our commits. That was our first commit, along with like, the date and the time, the author's email, um, and then currently head is pointing to main. Okay, great. Then we have one line. This displays one commit per line, showing the first seven characters of the hash. Okay, let's try that. One line. Cool, cool. That is very useful. Then there's a stat thing. Oh, it shows the information about, like, stats about files that have been changed and deleted and stuff like that. Okay, all right. This displays the files modified in each commit, the number of lines added or removed, and a summary line with the total number of files and lines changed. Okay. Then there's patch format. This displays the files modified, the location of the lines added or removed, and the specific changes made in each commit. Okay, let's try that. Oh, this is even more detail. Okay, yeah, this is okay. All right. So this is okay. This is great because at some point, I'm gonna be able to make use of VS Code's UI to make this stuff easier. So I'm kind of excited about exploring Git in VS Code. For now I'm still gonna stick with the CLI thing that I'm doing because it's teaching me a lot about how things work internally. Um, Once I've learned the basics, once I have a better understanding of how this system works, then I'll move on to the UI stuff. Okay, view a specific number of commits. Okay, all right. Starting at a specific commit. Okay. Graphical view. This displays the commit history as a graph. I wonder what that looks like in the command line. Showing how commits have merged and the overall structure of the repository's history. Let's try that. It also mentions one line. Okay, let's try git log. What is it? Graph? Yeah. Oh, it's a graph like that. I think there's nothing else being shown, probably because there's no branches. So that's kind of what the thing would look like even if I looked at it through VS Code. Actually, you know what? Real quick, give me a second. I have Zentrea's stream open and she just brought a couple of other people on stream and they are loud in the call. So I need to turn the thing down. Okay. Yeah. Like I was saying, in fact, if I open this up, I know I mentioned earlier that I wasn't going to do this, but like if I open this up now, you guys should be able to see it. Look at this initial commit, and it gives you information. It gives you all this information. You can click on each commit. This is basically the graph. And then um, there's a thing here. I think if there was something to commit, it would have shown something different. Publish branch main. Publish where? Okay, we can look into that. We can look into that later. All right, great. Um, right, awesome. So now we can. Where was I supposed to be? Here. Okay. Um, pulls down all the data of the repository, and checks out a working copy of the latest version. Okay. What does it mean to check out? Okay. Um, let's give some context. When cloning a Git repo, what does it mean to check out a working copy? Is that what it said? Wait, of the latest version. Of the latest version. When you clone a Git repository, the process of checking out a working copy of the latest version involves several key steps and concepts. Cloning the repo. When you use the git clone command, you are creating a local copy of the entire GitHub, no, the entire Git repository from a remote source. This includes all the version history, branches, and tags from the original repository. Okay. Initializing the local repository. The git clone command initializes a new Git repository on your local machine and populates it with the contents of the central repository. Where it initializes a new Git repository on your local machine and populates it with the contents of the central repository. This means it creates a new Git directory in the specified location, which contains all the necessary metadata and history of the project. Checking out the latest version. As part of the cloning process, Git automatically checks out the latest version of the files from from the default branch into your working directory. This is what is meant by checking out a working copy of the latest version. The working directory is where you can edit files, add files, and make other changes. The checked out files are the latest version. Words, dude. The checked out files are the latest versions from the default branch at the time of cloning. Uh, so so this is different from uh, the checkout that's done using the git checkout command. Um, this seems a bit ambiguous and confusing. I have to use these kinds of words just so it'll think that, oh yeah, there's like a big confusion, and it'll put extra effort into into trying to explain this. Okay, yes, the concepts of git clone and git checkout are distinct and serve different purposes. Although they can seem related due to the terminology, here's a clear distinction between the two. Git clone, the purpose is, okay, yeah, I understand what that does, but where's the checkout part? Okay, give me a second. Okay, purpose. The git clone command is used to create a local copy of an entire Git repository from a remote or local source. Sorry, zoned out. Okay, where was I? Okay, yeah, it's to create a local copy of an entire Git repository from a remote or local source. This command initializes a new Git repository on your local machine and populates it with the entire history of the project, including all branches, tags, and commits. Outcome. After cloning, you have a full-fledged Git repository with its own history, and it is connected to the original repository via a remote named origin. The working directory is set up with the files from the latest commit on the default branch. Okay. Git checkout. The git checkout command is used to switch between, okay, I know what that does. Okay, cool. It updates, wait, no, hold up. Switch between different branches, commits, or tags within an already clone. Okay, yeah, all right. I know what that does. It updates the working tree to match the specified version or branch. Okay. Outcome. When you use git checkout, you are changing the current branch or commit that your working directory is pointing to. This does not create a new repository, but rather navigates within the existing one. For example, you can switch to a different branch, check out a specific commit, or restore files. Key differences. Okay, git clone creates a new local repo. All right, fine, cool. No, okay, that's not what I'm confused about. Uh, I guess what I'm confused about is the fact that uh, checks out. What was the thing that I typed? Oh, wait, this was something else. Okay, real quick, there's going to be an ad playing in like 30 seconds. So I'm going to start the ad break right now, and I'll see you guys in 30 seconds. Okay, welcome, welcome back. So I guess what I'm confused about is, let me just read that thing again. Checks out a working copy of the latest version. I guess what I'm confused about is the fact that um, git clone checks out a working copy of the latest what? Commit or version? Version. What is it? No, wait. How is it checking out if it's cloning? Yeah, there you go. I think now it's giving me the answer that I was looking for. Okay, the confusion arises from the dual use of the term checkout in Git, particularly in the context of Git clone and Git checkout. Here's a clarification to help you understand the difference. Git clone and initial checkout. When you use when you use git clone to create a local copy of a repository, Git performs several steps. Cloning the repository, okay. Creating remote tracking branches. The clone operation sets up remote tracking branches under so and so and initializes the local branch to track the remote branch. Oh, okay. Checking out the default branch. As part of the cloning process, Git automatically checks out the default branch into your working directory. This is what is meant by checking out a working copy of the latest version in the context of git clone. Checking out a working copy of the latest version. So, checking out a working copy of the latest version in the context of Git, it basically means that once the repo is cloned, um, it does a checkout. So that head is pointing to the latest commit. Is that it? Or well, it's pointing to the latest commit of a specific branch. In this case, the I guess the main branch. I'm not sure. I'm not sure if you can specify a different branch to point to from the beginning. I guess I'll find out later. Okay. Difference from Git checkout. The key difference is that Git clone is used to create a new local repository and set up the initial working directory, while Git checkout is used to switch between different branches, commits, or files within an already existing local repository. Checkout in git clone is an implicit step where Git sets up your working directory with the files from the latest commit on the default branch. This is not the same thing as running git checkout explicitly to switch branches or check out specific commits. Okay, all right. So that's kind of satisfied my curiosity for now. We can carry on. Um, if you want to clone the repository into a directory named something other than so and so, you can specify the new directory name as an additional argument. Okay. The command does the same, that command does the same thing as the previous one, but the target directory is called so and so. Git has a number of different transfer protocols you can use. The previous example uses the HTTPS protocol, but you may also see Git or so and so, which uses SSH, which uses the SSH transfer protocol. Getting Git on a server will introduce you to words to the available options the server can set up to access your Git repository and the pros and cons of each. All right, cool, great. Give me a second. Okay, all right, cool. So now we are going to be moving on to this Git basics, recording changes to the repository. Recording changes recording changes to the repository. Why was that so hard to say? At this point, you should have a bona fide Git repository on your local machine and a checkout or working copy of all of its files in front of you. Typically, you'll want to start making changes and committing snapshots of those changes into your repository each time the project reaches a state you want to record. Remember that each file in your working directory can be in one of two states, tracked or untracked. Tracked files are files that were in the last snapshot, as well as any newly staged files. They can be unmodified, modified, or staged. In short, tracked words. In short, tracked files are files that Git knows about. Untracked files are everything else. Any files in your working directory that were not in your last snapshot and are not in your staging area. When you first clone a repository, all of your files will be tracked and unmodified because Git just checked them out and you haven't edited anything. As you edit files, Git sees them as modified because you've changed them since your last commit. Okay? As you work, you selectively stage these modified files and then commit all of those staged changes, and the cycle repeats. So you have untracked files, uh, you add the file because the file is not currently tracked, so you directly stage the file. Okay. If it is if it is an unmodified file, then you remove the file or you can edit it. Okay, if it's an unmodified file, from that point you can either remove it, or I'm trying to read this flowchart or this graph, whatever you want to call it, this diagram. So if it's unmodified, then you either edit it, at which point it'll become modified, or you remove the file, at which point it's untracked. Though if it's an unmodified file and you remove it, isn't that change going to be tracked? I think, okay, maybe there's a difference between removing a file from tracking versus deleting a file. Yeah, I think there might be a difference there. Okay, edit the file. Okay, once you edit the file, it's in a modified state. And since it's in a modified state, the next stage is to then stage the file. And staged files can be committed. So you commit the file, at which point the file becomes unmodified again because you have now committed the change. And then again, the process repeats. You can either remove the file or edit the file or whatever. Okay. Checking the status of your files. The main tool you use to determine which files are in which state. And this, my God, why was this so hard to read? The main tool you use to determine which files are in which state is the git status command. If you run this command directly after a clone, you should see something like this. Your branch is up to date with so and so, so and so. Okay, all right. Right, so I don't see this thing. Your branch is up to date with this because I haven't cloned a repo. I initialized one, but yeah, I guess like the point still stands. The rest is still the same. This means you have a clean working directory. In other words, none of your tracked files are modified. Git also doesn't see any untracked files, or they would be listed here. Finally, the command tells you which branch you're on and informs you it was that it has not diverged from the same branch on the server. Your branch is up to date with so and so. Oh, okay. All right. For now, that branch is always master, which is the default. Don't worry about it here. Get branching will go over branches and references in detail. GitHub changed the default. Oh yeah, okay. All right. Other Git hosts followed suit. Um, you may find the default branch name in some newly so and so so and so. Okay, okay. Yeah, that's fine. However, Git itself still uses master as the default, so we will use it throughout the book. All right, cool. Great. Let's say let's say you add a new file to your project, a simple readme. If the file didn't exist before and you run git status, you see your untracked file like so. Oh yeah, this would be a good use case because this file is not currently tracked, right? If the file was being tracked, yeah, let's step away from this and go back to bare bones. So if the file was being tracked, then it would show that, so and so file that's being tracked has so and so changes. But like if it's an untracked file, then what happens? Let's see. Um, uh, this file has some text. All right. Now we run git status. Okay, what does this say? It says on branch main, untracked files, so and so. Okay, real quick. Uh, Even more text. Oh, there it is. Okay, so changes not staged for commit and also untracked files. All right. Okay. Sorry, zoned out for a bit. Okay, back to this. You can see that your new README file is untracked because it's under the untracked files heading in your status output. Untracked basically means that Git sees a file you didn't have in the previous snapshot, in the previous commit, and which hasn't yet been staged. Git won't include it in your commit snapshots until you explicitly tell it to do so. It does this so you don't accidentally begin including generated binary files and other files that you did not mean to include. Okay, cool. So you want to start including README. So let's start tracking the file, tracking new files. In order to begin tracking a new file, you use the command git add to begin tracking the README file. You can run this git add README. If you run your status command again, you can see that your README file is now tracked and staged to be committed. All right, let's try that. Git add. Actually, what if I do this? What if I just use the lazy method? Okay, that worked. Great. Hold on. What does that say exactly? Changes to be committed, modified, new file. Awesome. Great. And there's also a way to unstage these changes. Cool. Cool. I'm sure it'll go into detail with that as well, because there is a thing about removing, or I think it said undoing changes or removing history or something along those lines. Actually, I think there's a section on this page for untracking files as well. I don't remember. Or unstaging? Was it unstaging? I don't know. Okay. If you run your status command again, you can see that your README file is now tracked and staged to be committed. You can tell that it's staged because it's under the changes to be committed heading. If you commit at this point, the version of the file at the time you ran git add is what will be in the subsequent historical snapshot. You may recall that when you ran git init earlier, you then ran git add so and so. That was to begin tracking files in your directory. The git add command takes a path name for either a file or directory. Wait, the git add command takes a path name for either a file or directory. If it's a directory, the command adds all the files in that directory recursively. Okay. Oh, maybe that's what dot does in this case, because generally like in uh like for example when you're doing stuff in the Linux terminal, I don't know if it's the same case with the Windows terminal, but like in the Linux terminal when you're doing stuff, if you want to refer to the current directory, you generally use dot. Like if you're trying to um I'm not sure what good example to give here. Like if it's something that absolutely requires the current directory and you're not able to, or the, the the program itself, the command itself is not able to figure out how to get the current directory, you can use dot to refer to the current directory, and then you can do slash whatever other directory if you want to refer to a subdirectory within the current directory. Anyways, the git add command takes so and so. All right, that's done. Staging modified files. Let's change a file that was already tracked. If you change a previously tracked file, oh, this is interesting. Okay, let's change a file that was already tracked. If you wait, no, I just did this. Okay, never mind. If you change a previously tracked file called so and so, and then run git status, you get something that looks like this. Changes not staged for commit. Okay, yep. the contributing.md file appears under a section named changes not staged for commit, which means that a file that is tracked has been modified in the working directory but not yet staged. To stage it, you run the git add command. Git add is a multi-purpose command. You use it to begin tracking new files, to stage files, and to do other things like marking merge conflicted files as resolved. It may be helpful to think of it more as add precisely this content to the next commit. Okay, uh, rather than add this file to the project. You know what? Yeah, that does make sense. That does help. Let's run git add now to stage the contributing dot so and so. Okay, and then run git status again. Okay, so now we have a new file and a modified file. Both files are staged and will go into your next commit. At this point, suppose you remember one little change you want to make to you want to make in contributing.md before you commit it. You open it again and make that change. You open it again and make that change, and you're ready to commit. Sorry, zoned out. Okay. You open it again and make that change, and you're ready to commit. Wait, if I make another change, don't I need to stage? Yeah, don't I need to stage the file again? Yeah, you need to stage the file again because there was a change, but now there's another change. What the heck? Now contributing is listed as both staged and unstaged. How is that possible? It turns out that git stages a file exactly as it is when you run the git add command. If you commit now, the version of contributing.md as it was when you last ran the git add command is how it will go into the commit. Wait, where was I? Yeah, not the version of the files as it looks in your, not the version of the file as it looks in your working directory when you run git commit. If you modify a file after you run git add, you have to run git add again to stage the latest version of the file. Okay, I wonder what that change, how that change gets added up, like how that extra change gets recorded internally. I'm curious about that. I guess I'll find that out by looking at git internals. But like for now, just a sort of high level understanding is enough that yeah, it's able to add that extra change as well. Okay, short status. While the git status output is pretty comprehensive, it's also quite wordy. Git also has a short status flag, so you can see your changes in a more compact way. If you run git status s or git status short, you get a far more simplified output from the command. Let's try that. Git status s. Oh, cool. Okay. All right. Yeah, that helps. Wait, what is, so there's M, which is modified, there's A, which is added. What is MM? So like modified twice, maybe? Let's try, okay, let's try something. Hold on. Let's try, okay. some more text. Okay. Oh, okay. So it adds up. It adds more and more to this. Then let's do git add and then status. Oh, that's interesting. Okay, all right. So that's where there's one. You know what I was initially thinking? What I was initially thinking was that maybe the number of M's is just going to keep increasing, but no, it doesn't. It shows an extra M which is red just to mention that there's a change that hasn't been staged. So there's a modified version of this that hasn't been staged yet, but there's also a staged version of the modified file. All right, cool. Wait, I think that's what they were. Oh, if I would have read this text, I would have probably figured that out. Okay, new files that aren't tracked have question marks next to them. New files that have been added to the staging area have an A. Modified files have an M, and so on. There are two columns to the output. There are two columns to the output. The left-hand column indicates the status of uh, the staging area, and the right-hand column indicates the status of the working tree. So for example, in that output, the README file is modified um, in the working directory, but not yet staged, while so-and-so file has been modified and staged. The rake file was modified, staged, and then modified again, so there are changes to it that are both staged and unstaged. Okay, ignoring files. Yeah, this is git ignore. I've used this in like with GitHub. It's kind of interesting because like there's different types of patterns that you can put into it to track different I think different file types, but also different file names and entire directories. Like there's multiple different types of patterns that you can create to ignore a bunch of things. I want to say it's simple, but it's not. It's fairly sophisticated. You don't have to learn all of it. You can just learn what's relevant to you. Like in my case, what was relevant was being able to ignore certain folders in a Unity project, for example, or being able to ignore, I don't know, um, the environment folder in a Python project because I don't want to upload the entire environment folder, stuff like that. Okay. Um, you know what? Let's see. Okay, viewing your staged and unstaged changes. Didn't we do that already? Like, isn't that already being done? Oh, diff. Diff is interesting. Yeah, I wanna look into that. Diff. There's also like it. So okay, this is gonna be within the CLI, right? It's gonna be within the terminal window. But when we start using Git with VS Code, we're gonna have access to more UI stuff. So there's slightly more prettier, slightly more better, I guess, ways of visualizing things. Um, yeah. Okay. You know what? Here's what we're gonna do. I'm gonna end the stream here. Okay. I'm not gonna raid anyone today. I'm just gonna relax for some time. Maybe I'll grab something to eat. And uh I don't know if I'm gonna dude, I wish I would have done my other stream earlier in the day. The mute stream. I wish I would have done that earlier in the day because I had the chance to do it. I just felt like doing something else at the time, so I was like, yeah, whatever. Um, maybe I'll do the other mute stream, the data science lab, the data science lab stream. Maybe I'll do it. If I do it, do. If I do it, it's gonna be maybe in an hour or 2 hours or something. Um, or it could be later. Maybe I might decide to not sleep or not be able to sleep, and then I'll do the stream. I don't know. I'll see. So, okay, this is one of the good things about these kinds of streams. Like, okay, so this is a talking stream, right? So I'm like, um, without going into details of why, I'm limited in I'm limited in the time when I'm able to do these streams. It's a short window of opportunity, and if I miss it, then I miss it. That's that, right? So I can't do these streams just at any time of the day, but the mute streams I can do at any time of the day. I can like pick any time and just start doing a data science lab stream. Yeah, yeah, I like that. I like that. So this way I have the flexibility that I could either do the data science lab stream before my mainstream, uh, or I could do it after the mainstream. I have that freedom. That's great. But yeah, dude. Okay, that's gonna be it for now. I don't know if I'm gonna be doing another stream, so I don't want to say that's gonna be it for today. Should I say that's gonna be it for today? I don't know. That's gonna be it for today. If I stream later, I stream later. Whatever. That's gonna be it for today. At least for the talking stream, that's gonna be it for today. I've just said that's gonna be it for today way too many times, but that's gonna be it for today. Um, I hope you guys have a nice day, and I'll see you all next time. Peace.